Hello, and welcome to this explanation video on circuit symbols for GCSE Physics and Combined Physics. Circuit symbols are a useful way to draw and communicate an electrical circuit. They are much quicker and easier to understand than either a drawing of a circuit or a picture of it. However, they do need practice to make sure that the symbols are drawn correctly. This video is going to introduce you to the standard symbols and their functions. You'll be seeing and using these symbols in other videos on electricity. For electricity to flow, you need a complete circuit and a source of potential difference. Without these things, charge will not flow. So when drawing a circuit, you need to make sure that your circuit symbols are connected correctly with lines, which represent the wires. There should be no gaps, and you need to make sure that there is a cell or battery present. This is a cell. It is a single unit that can provide potential difference to a circuit. This is a battery. This is many cells joined together to provide a potential difference to the circuit. Both components will provide a potential difference to a complete circuit. You need to remember which side of the symbol is the positive side, as this is not always shown in the exams. You should also know that the flow of electricity is considered positive to negative. Cells can be connected together to increase the potential difference in a circuit, but be careful to always connect them positive to negative. To find the total potential difference, add the individual potential differences. So here we have 3 cells correctly connected together. If each cell is 1.5 volts, then the total potential difference is 1.5 plus 1.5 plus 1.5, which gives 4.5 volts. Here we have cells that are not correctly connected. The first 2 cells are working against each other as one is connected the wrong way around. Their potential differences then cancel out. So the total potential difference here is only 1.5 volts. There are 2 ways to wire together a circuit, series and parallel. A series circuit is one loop. The current can only flow along the one route. A parallel circuit is more than one loop. The current can flow along more than one route. This is the symbol for an ammeter. It measures current flow in a circuit. Ammeters are always wired in series with other components. This is the symbol for a voltmeter. It measures potential difference in a circuit. Voltmeters are wired in parallel with the component. In practical lessons, ammeters and voltmeters can look alike. You need to look for the symbols on them to tell if it's an ammeter or if it's a voltmeter. All of the following are resistors. They all have the same basic rectangle resistor shape. This is a fixed resistor. It slows the current in a circuit. The value of its resistance, measured in ohms, does not change. This is a variable resistor. It also slows the current in the circuit. The value of its resistance, measured in ohms, can be changed. A thermistor slows the current in the circuit, and the value of the resistance measured in ohms can be changed by changing its temperature. The larger the temperature, the lower the resistance. An LDR, light-dependent resistor, slows the current in the circuit. The value of the resistance measured in ohms can be changed by changing the light intensity. The greater the light intensity, the lower the resistance. And this is a fuse. If the current flowing through it is too high, the fuse wire will get hot and melt. This will break the circuit and protect the appliance from damage. Other symbols you need to know include open switch, current cannot flow as the circuit is broken; a closed switch, current can flow; a lamp or bulb, this lights when current is flowing. This is a diode, only allows current to flow in one direction, the direction that the arrow is pointing. And this is an LED, a light-emitting diode. It only lets current flow in one direction, again the direction that the arrow is pointing, and when the current is flowing in the correct direction, the LED will light up. This circuit is correctly wired, the current is flowing in the correct direction and the LED will light. This circuit is incorrectly wired, the current is flowing in the wrong direction and the LED will not light. And that's all for this video. Thank you so much for listening.